Hello.
So you're back in school.
Yep.
Sounds like you're having the trig first.
Yeah.
Right? And that'll be like that for the whole semester?
Yeah.
Good.
And then I do precalc.
Trig and then precalc, right.
Yeah.
All right. So let's see. First we have to draw a sketch of Tiger Woods, right? I'm kidding. Did you read the instructions?
Yeah.
This is a teacher with a sense of humor, obviously. All right. All of these word problems are merely triangles that you need to solve. Triangle here that's 75. This is what we're solving for. X, the distance to the boat. And if this angle of declination, or the angle of depression, excuse me, is 40 degrees, which angle do we know in that triangle?
The one right next to the 40.
Well, okay, so that's
The
50.
one.
But
Yeah.
more importantly, that top line is parallel to my X line.
Yeah. So we also know
This
the
is
one.
immediate
Yeah.
one step. In other words, I could say that that's 50 and then calculate that this has to be 40, but why do two steps when you can do one? Now, simple manner of applying the proper trig function to calculate what x is. Now, always begin these equations with the trig function on the left.
Okay.
So figure out which trig function we need, first of all.
Tangent.
Okay, so you would begin by saying tangent of 40 degrees equals what?
Is it 75 over x?
And now that's just a simple equation to solve because tangent of 40 degrees is just a number that you're going to get off your calculator. So if I finish the algebra, it's the x is 75 divided by the tan of 40 degrees. And how do they want, that may be the way they want the answer, because the tan of 40 degrees is probably going to be irrational. It doesn't say. How far from the ship, from the space capsule, they want it in feet. So you would have to put that in your calculator to come up with that number.
Yeah, I'll do that after.
Okay. Another problem, another triangle. All of these are right triangles. Good thing, because we wouldn't know how to solve it if they weren't. So that's 9.3, that's 7.4. What are they asking for? Find the angle of depression from the camera lens to the entrance door. Well, there's the camera. The angle that they are talking about is that one, not the one below it. Okay? The angle of depression is always the same as the angle of inclination. If you were down here looking up, this would be the angle of inclination. Same as the angle of depression as long as everything is parallel lines. And they are here. So again, to solve for this angle of depression, we have to solve for this theta here. What's my equation?
It would be tangent of theta over 7.4 over 9.3.
Okay, equals that.
Equals that.
Okay, so how do we solve for theta? Since that's what they're asking for.
Don't you take the tangent to -1?
Well, that's called either arctan or inverse tan. We'll call it, what's your class call it?
We haven't really talked about it again.
Okay. Probably inverse tan. And it's important to understand what inverse tan is not. It is not 1 over tan. In other words, if I said 3 to the -1, that's the same as 1 over 3. So this -1 has a different meaning when it's being applied to trig functions. Okay?
Yep.
That's just a button on your calculator. What kind of calculator do you have this year?
GI Inspire.
Okay. That's good. You know how to use it well, don't you? It seems like you were pretty good with it last year. There's a trig button on there, and when you hit that, it brings up all 6 trig functions and all 6 inverse trig functions. Only on that Inspire, I believe they're called arctan and arcsine and arccosine. Same thing. In other words, I can write that arctan is the same thing as inverse tan. The important thing is that we use inverse tans or inverse trig functions to find angles. We use trig functions to find ratios. Very important distinction. The other way you can kind of look at this, I mean, this is by definition, this is an if and only if from geometry. The tan of theta is equal to that if and only if theta is equal to this angle. And that will be an angle. And depending on whether your calculator is in radians or degrees, you'll get an angle. But the one thing that's a little tricky about that Inspire is determining whether you're in degrees or radians. I can't believe any of these calculators don't, when they give you the answer, they don't put either degrees or radians on it. You have to know what mode your calculator is in. And that Inspire, it's tricky. It took me about 5 minutes to find that, how to change from radians to degrees. It's hard, much harder than the TI-84 was, let's just talk about this for 1 second here. If I say the sine of 30 degrees, in other words, the sine of an angle, equals a ratio, then I can say that the inverse sine of 1/2 equals 30 degrees. Again, these two things mean the same thing. The other way I can look at this is I can take the inverse sine of both sides. Remember in algebra, you can do the inverse sine, or you can do anything you want to one side of the equation as long as you do it to the other. Well, if you combine inverse sine with sine, you're left with just the angle. And that is equal to the inverse sine of 1/2. So either way to think about it, I prefer not to use that technique, but merely to use the technique that the sine of an angle is a number, therefore the inverse sine of the number is the angle. Okay. Another problem that's just a triangle. Only difficulty of these is making sure you get it dimensioned right. In other words, understand what the words mean. If a guy wire for a tree is 14 feet long, making an angle of 41 degrees with the ground, how far are we away from the tree? How do I draw this and label it? I'll draw the triangle. You label it for me. This is the tree.
Yeah. The hypotenuse is 14 feet.
Okay, that's the guy wire.
And then the lower right corner is 41 degrees.
The lower right angle, yes, correct.
Yeah.
That angle right there. Because that's the angle made with the guy wire and the ground. Okay, so again, it's just another triangle problem. Which trig function should I use here? And we're still trying to figure out x. In other words, they didn't ask us how high the tree was, which would have been difficult without something else, but we certainly can figure out how far away from the tree we are by using which trig function.
Cosine.
Yeah, let's back up 1 minute. What if they would have said how high is the tree?
No. I probably would have done,
Could use sine.
yeah, or, yeah.
Sine of 41 degrees is the height of the tree over 14. There's only one variable there. So, in other words, given one angle and one hypotenuse, we can calculate everything else. What's the trig function? Cosine of 41 degrees equals x over 14. So x is equal to 14 times the cosine of 41 degrees. And you can do this all in one step on your calculator, I'm sure you know.
Yeah.
All right, so here's my escalator. Makes an angle with the ground of 10.36 degrees and has a vertical rise of 195.8. Which side is that?
It's the opposite to the angle.
Okay, the vertical side. And give me a trig function. We're trying to find the length of the escalator.
So it'd be sine.
Yeah, this is a little tricky. Do they want the hypotenuse or do they want the distance to the wall? Well, the length of the escalator, I would say, is the hypotenuse.
Okay.
So sine of 10.36 degrees equals 195.8 over x. And Multiply both sides by x, divide both sides by the sine of 10.36, and again, you have your answer.
All right.
I personally would just as soon see them give you just the triangles. I don't know. If they're teaching trig, just give the triangles. Don't disguise all of these in word problems. I mean, there's a time and place for these, for sure. But why make things more confusing? All right. So we have two ships. Being sighted from the same point, and this angle of declination, or depression, excuse me, is 28 degrees, and this complete angle here is 53 degrees, is the way I interpret that. Yeah. How far apart are the ships? So we need that distance there. All right, well now we're having a good problem here. From a height of 38 meters above the seawater, that's 38. And they want to know x.
Could you
Any idea?
find both the distance from the first ship to the land and then the second ship to the land and subtract the two?
Okay, let's do that.
Or is that overworking the problem?
No, let's do that. It actually will work. We have two triangles, both right triangles that we're dealing with. One, there's one, and this one is the second one. Between those two triangles, we're going to be able to figure out everything we need to know. So, let's first of all figure out what this distance is. Give me the equation, or actually, one minute, I've got to think about this for a second. Whoops, I should let you do that. All right, let's solve this little triangle here, which will allow us to solve this distance here. In fact, let's call this ABC. Let's solve for BC. Give me a trig equation that'll let me solve for BC.
The tangent of 53 equals 38 over x, or
that's why I put letters on it, BC. Okay, and that indeed is going to let us solve for BC. BC will be 38 divided by the tangent of 53. And now let's solve for AC. Not AB. We don't have yet the means to solve for AB because that's not a right triangle. In other words, this triangle here is not a right triangle. So we can't immediately solve for AB. But if we can solve for AC, we'll do like you said. We'll subtract AC minus BC will give us AB. So how do I get AC?
it'd be tangent of 28 equals 38 over AC.
So AC equals 38 over the tan of 28. And finally, AC minus BC equals AB, which is what we're trying to find. So we have 38 over the tan of 28 minus 38 over the tan of 53. And that's going to be your answer for the distance between the two boats.
All right. That's all I had for homework.
All right, let me give you one. It's kind of a clever one. That's Pikes Peak. You're in a wagon train, the very first people that have come across Pikes Peak.
All right.
They want to know how tall that mountain is and how far away they are from it. And so they find an angle of inclination of 20 degrees. They move forward 1,000 feet. You can do that. You can measure how far you're going to roll your wagon forward. You take another reading on the mountaintop. This time you get 30 degrees. How do I solve for the height of the mountain, which is y, and the distance to the mountain, which is x? And I can solve for both of those numbers. And this is actually very practical. Probably the more important thing they cared about was how far they were away from the mountain. But they also had to cross the mountain. So they wanted to know how high it was as to whether it might be worth going this 100 miles to get there. So how would I do this? We'll call this x. Give me some trig equations. As you can see by now, tangent is a pretty good one. Let's start with this outside triangle, this triangle right here. What's the trig function? Go ahead, just give it the way we've been doing it.
Is a tangent of 20 is equal to y over x?
Okay. Notice from that alone, we cannot calculate either y or x. We got one equation and two variables.
Yeah.
But now, just by moving some distance forward, it doesn't have to be 1,000 feet. It could be a mile. It could be anything. And now you take another one, and now let's deal with this triangle. Give me an equation.
It'd be tangent of 30 equals x over y.
No.
Or y over x.
No, this distance is not x.
Oh, is it x minus 100
X minus
or 1,000?
1,000. That's all you need. You now have two equations and two variables, and you can use substitution to solve for both. In other words, I would solve this one for y, I guess, and then substitute my answer for there, and then I got one equation and one unknown, and I can solve for x. But I've always thought that this is a very, very clever, tricky application of trig. because with only 1,000 feet of movement, they figure out that they are 100 miles from that mountain. And that's when you see Pikes Peak. I don't know if you've ever driven in on I-70 or not, but you see Pikes Peak on a clear day when you get about 100 miles from Denver. And then, of course, once you know that, it's relatively easy to figure out why. But it's a good problem. Do you have a textbook?
No, not yet.
You going to get one, or are they going to do it all online, or?
Yeah, we're going to get one, but we have a packet to start because all of our teachers were giving us textbooks. She didn't want to falling over.
Oh, okay. You don't, do you happen to know which textbook it is?
It's
Is it the one by Demana, Waits, Finney?
it's the white book with yellow writing.
That's the one I got.
Yeah.
Good. I'll be able to know exactly where you're at in that book. Okay. And I might add that the very first chapter in Trig in that book is chapter 4, I believe. In other words, that book you're talking about actually starts with precalc and does trig on chapters 4, 5, and 6, if it's the same one I have. But I'm going to tell you, they make it a little confusing to start. Just like every math course, it doesn't matter whether it's algebra 2, geometry, trig, precalc, or calculus. They all are insistent about starting out with difficult concepts and then going to the easier stuff. But that's my impression of that book, is that the very first 10 pages are almost the toughest stuff in the book. I mean, I'm not going to say that, but that's a little strong. But still, it's a little tricky. Some of the stuff they talk about in the very beginning of that. All right.
Yeah.
When are you scheduled to take the ACT? Mid-October?
No, I'm going to wait and take it the first time we have to. So, like, April.
Oh, okay.
And get completely, fully ready.
Okay. You're a junior, right? Yeah. So you'll take it in April, and then you'll have another chance to take it either in the summer or next fall.
Yeah.
You know where you're going, where you want to go to college? Any idea?
I was going to try to go to the CU in Denver, which is way cheaper and same teachers as the one in Boulder.
Oh yeah, no, I'm sure that it's just as good.
So that's where my brother went, and then I'll try to go up to CSU.
Oh, you're gonna go? Oh, for like a couple of years, you'll go to the one in Denver, and then you'll transfer to CSU?
Yeah, I'll get all my easier classes done, all my basic classes done at UCD, and then go up to CSU for career-driven stuff.
Sounds like a plan. All right, Mitch, I will talk to you. Are we going to keep our schedule?
Yeah, it's going to be later till like October because I have golf practice.
Okay. So let's see. Right now I got you on Wednesdays at 4. Do you want to change that while I'm with you? I mean, while we're talking? What do you want to change it to?
Like 6.
Okay. I'll just move it right now.
Yeah.
You got 6 o'clock for that, and oops, I'll fix it. But yeah, wow, I didn't like me changing that. I may have to do something special, but I'll make it 6.
All right.
All right. All right. Talk to you later.
All right. Thanks.